Bismillahirrahmanirrahim. Dear students, I am Ahmed Mumtaz Mustahsan, your teacher for CSC 141 Introduction to Computer Programming. Students, today we will discuss a very interesting topic, and that is the file processing. And once again, I have picked up this lecture from your reference book, See How to Program by Detail in Detail, and I think this chapter number is 11 of the book. Okay. Students, we have seen in our different programs that we create data, we process data, we store data and store it into the computer, into the structure that we defined. Structure could be variable name, structure could be arrays, structure could be a structure itself, or it could be a pointer, or it could be union, or any storage location of the computer. But most of the time we are dealing with the primary memory of the computer. What does it mean? As I explained you in the very beginning, that once we switch off or once we exit from our program, all the data that is processed and that was saved into different structure is lost. So what do we need to do? In order to save all the processed data, we need to have something where we should keep all the processed information. So for that purpose, we can create files. We can create data files, and we can store data in the data file. Then we can save these data files onto the permanent storage device or a secondary storage device. And this secondary storage device, in our case, in our scope of this particular lecture, is the hard disk. Okay, so we'll be creating the file on the hard disk and we will be using it. So in one program we will create a file, and in another program we will open that file and we will use that data and process it and update it and again save it back onto the disk, so that at any time when you are required to process the data, you can retrieve the information. Retrieve किसे कहते हैं? To extract the information from any structure. So if you want to read a file from the structure, you can retrieve the file from the structure and then you can use it as per your convenience, like the banks, like the reservation systems, like any online system or processing system, transaction system, where the organizations keep track of the data and keep record of the data of their clients onto the system. So where do they record this data? Where do they archive this data? Usually and mostly they archive it onto the computer, and usually it is on the disk and in the form of files, and mostly in the form of data files. So we can data can be created, updated and processed by the C programs, and this permanent storage are used to archive the data permanently or as long as you wish to keep it. Okay, before we move directly and jump in directly to the files, we should start from the beginning, that how we process the data, how we produce the data. So basically, you know, the computer is a device which is called a bistable device. It works in the binary number system. Binary means it's 0 or 1, a number system which has a base equal to 2. So the binary number system, you have a digit 0 or you have a digit 1. So ultimately, whatever type of information is, it is end of the day or end of the processing, it is converted into zeros and ones. So let us start from 0 and 1 and move upward to see how this information is organized. We have over the bits, we have a byte. Usually there is 8-bit. The convention is that a byte is 8-bit, and usually the character data, the system that we use it we already have introduced. I have explained it to you. It is American Standard Coded Information Interchange. It's called ASCII code, and that ASCII code is 8-bit code. We have another code which is ABCD code, that is also an 8-bit code, and there is another code which is also known as a Unicode, that is a 16-bit code. But in this particular course we have not used the Unicode, and it is basically the provision which is provided by the operating system. So we are dealing with the code which is an ASCII code. So what type of information we can store it into the byte? It is usually the combination of bits, and that combination of bits means 8 bits, and these 8 bits forms one character. And then you can have a combination of characters to have some useful information, to input and output some useful information, for example over name, and the name comprises the set of characters, so you are required to combine these bytes. But if you are talking about some other type of data, for example an integer data, in the integer data we have the int data type, which is could be of 2 bytes or it could be of 4 bytes, but in our case we have seen that it is of 4 bytes. So whenever a decimal number that we put it onto the computer in the form of the integer, it occupies 4 bytes. And there is another concept that I had explained it to, which is called a word, that is word boundary. Word boundary means that the memory which is accessed by the computer in 1 unit is usually 1 word, but in the form of the data processing, from the byte we have some useful information which is basically the combination of bytes. This combination of byte means that you have the unit information that provide you one particular information which can be considered as 1 unit. For example, your name, your national ID number, your telephone number, your balance account, your bank account number, and your salary. These are all, when we consider it, so each entity we can consider it as a field. Then we have a combination of field, combination of the related fields. For example, if there is a name, it's my name, and then I say if I'm putting up my name, then there should be my ID card number, then there should be my account number. So it's mean that the fields which are logically combined together to represent one entity, and that entity is called a record. So record is basically a combination of fields. So in C language we represent a record with the help of a structure. Aapne dekha, we can define within a structure, we can define name, first name, last name, the salary, the balance, the account number. We can do that, and we can put it up into the form of one structure. Or there is something else which is called a class, but that we use it in the form of object-oriented language, and in the framework of object-oriented language, and we have not touched that in this particular course because that would be our next course. So we will be restricting ourselves to whatever we have studied. So then we have the set of records. Set of records means that there is a record of one employee, then there is a record of second employee, there is a record of third employee, and there could be, let's say, 100,000 employees, and then you want to keep track of the information in the form of record. Means for the employee record, and that employee record should contain the employee ID card number, your employee number, employee name, first name, employee last name, employee's father name, and lot more information related to your, maybe for if it is related to your salary, then you may call it as a payroll. It's a payroll, basically a set of records combined together. When we combine this set of records, then it becomes the file. Okay, so the set of records of one particular application, there could be multiple files. For example, if we are talking about the financial system and we are talking about the salaries, so we might be talking about a payroll file. But if we are talking about the inventory system, then containing the name of the article, the name of the item, its specification, its size, its price, its date of purchase, its date of the life of that particular item, for example, and so you can have a number of files. Then in one particular organization you may have hundreds and thousands of files, and then you need to organize those files together in the form of one information system. So when you combine and group different files under one particular information system, then it becomes the database. So we have put up all the information in the form of files, and the set of files is called the database, but the database cannot be completed if there is a control information management system attached to it, how this information should be organized, how this information should be retrieved, how this information should be backed up, and how this information should be updated and deleted. So basically, and the storage mechanism also, what type of file you are going to produce in order to save that particular information. So this storage and retrieval system, the management system, is called DBMS, database management system. Okay, so this is basically called the hierarchy of data that we need to process. It was important to discuss before we could go up to the file processing. So since we'll be stopping here in this particular course up to the file, so we can say that we can start with this file could be start from the least point, which is bit, and then we can have a combination of bit which is called byte, and then we can have this byte combination of bytes. Okay, so from 1 bit we have an 8-bit that produce 1 character, and this 1 character could be, let's say, J. So then we have a combinations of characters. These combination of character will form one field. Okay, and this one field is here. Then we can have a combination of fields here, and these multiple fields that we can have, and this combination of field is basically called a record. And then we have a combination of records here like this, and these combination of record organized into some system is called one file, and that is the data structure, that is the structure, that is the objective of our today's lesson. Okay, so there is one more concept that is related with the field and related with the record. In the record we have got the set of fields, and among the set of fields there is a field which is a very special, there could be one very special field, and this field could be used to retrieve the data. To retrieve the data means to extract the data from the structure, and that's why this field is called a key. And key is basically one of the fields which uniquely identifies a record, and you use the key field in order to search the record and in order to extract the information out of the record. Okay, so that is another concept which is related to the files and processing of files. Then comes the types of the files. If we organize the records one after the other, what does it mean? That we record we save and archive the record, and then at the end of this archiving of this record, what we want, that how should this records be organized together? Do we need to organize it in a form that it could be extracted randomly, or should we want to access the file sequentially? Sequentially means in a sequence. Sequence means one after the other. Okay, we have done already the sorting where we have organized the data in ascending order, in descending order. But here we say that the records are organized one after the other. It might contain, a record might contain a key also, but yet we wish to organize the records in the sequence. So we then produce a file which is called a sequential file. Then there are few more features related to the sequential file that I will discuss as soon as I move forward and introduce some more concepts. So I'll be starting with a sequential file. So C views each file as a sequence of bytes. Now I'm a sequence of record ki baat nahi kar raha. The C language, the C compiler, views the file basically in the form of sequence of bytes. This sequence of bytes is called basically a stream. Okay, it's a stream of bytes basically. So when you know that the file can start, and then you can have one record, then after you can have another record, then you can have another record. So you keep on adding the record, but these records are organized by the programmer, not by the compiler, not by the system. So for the system it is a sequence of bytes, it is a stream of bytes basically, and at the end there is a very special byte that contains a special data which is called end of file. This end of file has a special representation in operating system. For example, in our Windows operating system we use control sequence, means control Z. When we hold control and press Z, then we press control Z key, and this control Z key indicates the system that this is the end of the file. So basically when we create a file, I already said that the system treats it as a stream created when a file is opened. Whenever we have to create a file, the first step that is most important is open a file. Open a file means you are required to establish a channel, a communication channel, a communication system between yourself and the operating system, so that whenever you demand the system that we are going to read the data from the file, as long as you are reading the data from the memory, the operating system does not come into this. You are directly handling the different memory locations through your program. But when you are dealing with the files and you are dealing with the devices, and in our case the device is the hard disk, in that case you need the assistance of operating system to access the data from the hard disk. So for that purpose you need to establish and provide a communication channel between the files and the program, and this facilitation is provided by the operating system, and the request is generated from your program to the operating system. So whenever you open up a file, a pointer to the file, which is pointed to a file structure, is automatically created. So I'll explain it later on, that what does it mean pointed to a file, and but something is very important to understand, that there are few streams that are open up by default. What does it mean? I've said that whenever you are supposed to deal with the files, you are required to create a file pointer or file structure. So you are required to identify the file streams. But there are three streams which are by default available to you all the time. These three streams are stdin, stdout, and stderror. Stdin, what it does? Basically, stdin is a stream that reads the data from the keyboard. Although you can read the data directly through your computer program, but if you want, you can treat the keyboard as a device. In that case, you can read the information from the keyboard with the assistance of operating system. In that case, you need to read the data from the stream, and that stream is called stdin. So you can read it directly from the keyboard, but this time you will assume that keyboard is a device and you are reading it from the device file, keyboard file, and you will use a stream stdin. Similarly, if you want to display the output result, or if you want to display the error, you will use the output, which is the std out, which is the stream, and that stream is basically called std out. So std out and std error both represents the screen of your monitor or screen of your LCD of your computer. So these are the three streams which are by default open up. But for the file where you want to perform the read and write by yourself, for that purpose you need to define the file descriptor. So मैंने अभी आपसे कहा था, I'll explain it to you, कि what is the file descriptor. So file descriptor is basically an index into an operating system array called the open file table. Whenever you open a file with the standard command, so you create a pointer to file. This pointer to file is a table. That table contains a pointer. But this is the pointer that you use to communicate with your file. But how does the operating system facilitate to you? This pointer on the other side contains an address of a table, which is a file control block. So operating system from this point refers back to its own table, which is a file control block, and that file control block contains the information of the related file that you wanted to deal with, that particular file you wanted to deal with. Okay, so for your convenience, for our convenience, for the convenience of a programmer, we are just required to communicate with the up to the file descriptor, file pointer, and then it's not your heading. This is a transparent. Then you assume that you are reading it from your file. But in between, this file pointer helps the operating system to take it up into the operating system table, which is a file control block, from where the operating system picks up the information and retrieves the information and provides it to that particular program or that user that has demanded the use of that particular file. So whenever you want to create a file, you are required to have a file descriptor, which is a file pointer. Whenever you want to read it, you should know that you have to open it up. When you open a file descriptor, means you are creating a file. You are creating a file that already exists, or you are creating a new file. Okay, I'll explain it further with the help of examples later on. So file streams, मैंने आपको बताया, basically file stream is nothing but the sequence of bytes for the system that ends with a very special marker, which is called end of file marker. And in our environment, in the Windows environment, this end of file marker is basically Control Z or Control Z. Okay, let us discuss how we are going to read-write a file. There are certain standard library functions which are available. So we will be using those functions to perform the communication with the file. So if we want to read a character from a file, we can use fgetc. This fgetc basically has a format which is equal to this format, fgetc, okay, which is equal to getchar character that you already have, that you use it because you want to read it from the keyboard. But this will read the character from the keyboard, and this fgets will read from the file. But if we use stdin, and stdin is a device which is a keyboard, so इसका क्या मतलब हुआ? It's mean that fgetc, stdin or getchar perform the same task. The difference only is that here your program is directly communicating with the keyboard and reading up the data, obviously with the help of operating system also, but that is not in the form where that you have requested operating system that you are going to deal with a file, and this file is a stream, and this stream is the keyboard stream. So basically you takes a file pointer as an argument, this for fgetc, you provide the file pointer, file static ptr, or in case of reading from the keyboard, you will use stdin. Similarly, You can f put c, you can put a character from, you can put any character that you pass it on to that library function put char, and this function will display the data onto the screen. But if you want to do it through screen, stdio means file stream, so you will use this stdout, and you will use f put c. This is the character that you want to display it onto the screen, and this is the device stdout. So this f put c is equal to put char, और difference इसका वो ये जो मैंने आपको यहाँ पर explain किया for the get c, जैसे कि keyboard के साथ है. Then f get s should also be in a blue color, but f get s means it reads a line from a file. It reads a line. Just like get s, what it does, get s reads a line from the keyboard. But if we use f get s, it reads a file, one line from the file. And again, it has got the syntax that I will explain it later on. F put s, just like put s. Put s क्या करता है? It puts one line onto the screen. But f put s puts one line into the file. F scan f and f print f. These two functions, set of functions, scanf and printf, or getS and the putS, the difference is that these are the functions which are basically used for formatted input and output. If you want to have a control of the format, if you want to control the format while reading the data, you use scanf. Similarly, if you want to control the format while reading the data from the file, you will use fscanf. But if you want to read the data block by block, line को हम extend कर देते हैं concept, block by block, if you want to read the data, then you will use fgetS. If you want to write the data into the file with a controlled format, with a format of your choice, then you will use fprintf. But if you want to put the data in block by block, then you will use fputS. So this is basically the difference. So let's move forward to the next slide. Creating a sequential file. No notion of record in a file. What does it mean? I have already explained it to you, that for C language the file is stream of bytes. इसका क्या मतलब हुआ? इसका मतलब बड़ा आसान है, बड़ा सिंपल है कि C language does not know what is the structure of your record. It's mean that the stream of bytes, you will write it down knowing the structure of the record by yourself. So when you write it, you will know the structure. When you read it back, you should know the structure as a user, as a programmer, as a creator of that particular file. But for operating system, there is nothing in the sequential file which is called a record. So you are directly dealing with the system, with the files. So you have a file, you have a stream of data, and that is a stream of byte. But when you read the data from the file in the form of the stream of bytes, then the interpretation of those bytes to put the data in the format, in the structure, you have to carry out the task by yourself. So programmer must provide that particular structure to read and write the data. So how can we create a file? First of all, we need to create a file pointer, and that file pointer, the type of that file pointer, the prototype of that file pointer is file, usually written in uppercase, pointer, and then you can use any variable that you want, and that will represent that this is the pointer, that is a pointer to that particular file. So after creating this pointer, now you can use this particular pointer in your program, and you have to load the address of to that particular pointer, and this address will be the address of that particular file. That is mean, what does it mean? It's mean that the file descriptor, जो भी मैंने शुरू में आपको explain किया था, that I talked about a file descriptor that contains a pointer that is used by the operating system to read and write the data from the file. So we are not going to load the address here, but we are going to load the address with the help of a function which is called fopen. So we will use a function fopen that will return the address, and that it will return a pointer to a file. So you have already declared a pointer to a file cfptr, then you can say that cfptr is equal to fopen, then you can provide the name of the file, then you can use the word here w. W means that you are going to read a file for writing, create a file for writing. Okay, it's mean that if the client.dat file does not exist, then the system will create a file, and it will open up the file for you and provide you the information that will be saved in this file descriptor. In this particular example, it is cfptr. So function fopen returns a file pointer to be specified, and this address is loaded in fptr. Now whenever we want to read or write the information, in this case since we have opened the file just for writing, so whenever we are required to write the data into the client.dat file, we will use not client.dat, rather we will use cfptr. That is a file descriptor associated with clients.dat, and this association is done by the operating system. So when this function, this system call is executed, operating system will create the file, okay, for you, and return the file descriptor that will be saved in the file control block, and as well as it is returned back to you and it is saved in your file structure, and the information is copied back into cfptr, that the pointer to a file that you have created. So fopen takes two arguments. One is the file to open and the mode. This is called mode, and we have opened up the file in writing mode. So if open fails, what the operating system is going to return? If this function fails, then operating system is not going to return any address. It will return null, it will return 0. So it's mean that if fopen returns a value which is equal to null, it's mean that the system has shown its inability to create the file. Or when the system will show its inability to create a file, obviously when there is no disk space. अगर disk space नहीं है किसी वजह से, you cannot access the space where you want to create a file, then the system will give you a null return address. Then there are few more functions that you can use while you can communicate with the sequential files, and these functions are fprintf, that used to print a file line by line. It's fprintf, obviously you will write the information. Used to print to a file means you are going to put whatever the format of this fprintf is, that I will explain you with the help of an example later on. So that it will write it down. Printf writes down onto the screen, but fprintf writes down onto the file. Then end of file pointer. It's a good programming practice. Basically, you are supposed, when you open a file, so at the end of your program you are supposed to close the file also. Okay, it's a good programming practice to close the file as well. Otherwise, if you will not close it, it's mean that when you will exit from the program, then by default the operating system will close down the file. But it's, as I said, it's a good programming practice to close the file. Okay, file, end of file pointer. This function basically returns the end of file indicator. Suppose you are reading from the file and you encounter that end of file. It means that no more data can be read and the file pointer has been read. Similarly, when you close a file, then automatically the system insert end of file, so that the next time when you are going to read that, then the end of file pointer indicator marker should be there for your convenience. Okay, close specified file, you require to close it with the help of fclose and perform automatically when the program ends, but good practice says that you are required to close the file explicitly. So program may be process no files, one file or many files. It's up to your requirement, it's up to your use that how many files you want to create through one single program. So you can have your program may create no file, or your program may create as many files as you required. But each file that a program is going to open should have a unique name and should have its own pointer. Unique name is just like when you create a file and the file name is already there, then the system indicate an error message that file already exists. So that could another reason that the system is unable to create a file, that the file already exists if you want to create a new file, for example. So let us take an example. All the concepts that we have studied so far under the creating a sequential file, let us go through it step by step and see how can we create a file. This is the program, and we have declared three, it's not the structure, but rather we have declared three variables. Integer account, that may represent the account number, then it has character name, and we have given 30 array of name, then double balance, that could be the account balance. Then we have defined a file descriptor here, pointer to file. So CFPTR is a pointer to file that we will use to create a file that is called clients.dat. Use the same name because, or whatever name you will use, because later on in the next program we will use the same name to retrieve the information. So fopen opens file, exit program if unable to create file, means कि मैंने आपको बताया कि suppose अगर disk space नहीं है, there could be another reason also. So if the system fails, then it will return. So it will return a pointer, and suppose if this pointer is equal to null, and when you read this null value is equal to null, it means that the system has failed and you can display a message. But this is printf, means you are directly writing it onto the screen. So you can write down onto the screen file could not be opened. Okay. Otherwise, if the system is successful in creating the file, then you can say that okay, you can put up the data, and first of all we will produce one record, and then I'll show you in the next page that we will use it up for putting up multiple records there. So we can say enter the account, name and balance. Three fields are there that we have defined: account, which is integer account, name, which is a array of character, and balance, which is double. So you will enter there and enter end of file to end the input. It says that keep on entering the data, and terminate it with enter the carriage return or enter key. But once you entered the complete data, then you can use the end of file, or हमारे case में what is the end of file? Control Z. We can use a Control Z that will indicate the end of file. Okay, so first one is integer, so use %d. Next one is character, use %s. Third one is a double, so we can use %long lf, that is long double, or long float, which is a double, and this address of account. Name के साथ हमने % sign नहीं use किया, you know that, because this is the name of the array, which is the address of the array, and then the address of this variable balance here. Okay. So then we can have a loop here, while loop, and this while loop says that unless until you encounter end of file, keep on reading the information. So you will keep on reading the data from the keyboard and keep on writing it onto the file. So you have to be very careful. We have already read one record. That record means that we have already got account that contains account number, name and balance, that we have read it here in the previous. So we are writing the first record here. then we say print question mark. Question mark means, do you want to enter another record? So if you just enter another record, then the record will be entered and you will just keep on entering the data. So but if you stdin enters end of file, means for the input of this scanf function, if you press Ctrl Z, that means you have indicated a scanf function that this is end of file, and since scanf function reads it from the stdin, it's mean that the stdin has encountered end of file. Okay, so it's mean at the result of this particular statement, if you enter the Ctrl Z, if you enter a Ctrl Z here, in response to this question mark, you will enter a Ctrl Z here, then it will read a Ctrl Z and this while loop is terminated. Otherwise you can keep on entering the data. So once you enter the Ctrl Z, then you can close a file and then you can return, because it was int there. So this is the execution of the program. So this program is basically enter the account name and balance, then enter end of file to enter data. So you have entered account number 100, name, then amount, account number, name, amount, account number, name, amount, account number, name, amount. So basically this is the debit credit transaction. Positive means you are depositing the rupees or depositing the money into your account. Minus means you are retrieving the money, or you are getting the cash from your account. Okay, you are drawing the money from your account. So once you enter the Ctrl Z here, this is the basically end of file, and Windows environment, this is the Ctrl Z that indicate end of file. So this you can see that this is terminated. Okay, so we have seen the example, and we have not yet seen that whether the data has already been recorded or not. We will use it when in the next example when we read the data. So in the Unix system, it return Ctrl D, return Ctrl D indicate that, carry return Ctrl D indicate end of the file. IBM PC compatible environment where we are working uses Ctrl Z that indicate end of file, and in Macintosh, Apple Macintosh or iMac machines, you are required to enter Ctrl D to indicate the end of file. Okay, we have used a mode, and this mode we have used somewhere at the time of opening of the file. This is the mode, this W. Okay, this is the mode. So is there only mode? No. You can open a file in different modes, and that different modes are all listed here. So we can use R, means open a file for reading. W means that you can create a file for writing, and if the file already exists, then discard the current contents. What does it mean? File already exists, you have opened a file again for writing. So what will happen? The contents that was already entered into the file will be lost. So you have to be very careful whether you are going to update the file or you are going to open the file to write. So this file, this W is the mode that if the file does not exist, it facilitates you to create a new file. But it is dangerous that if the file already exists and if you already have got the data, then you should not open it up. And if you want to retain the data as well, then you should not open it up with the help of the mode W. So उसके लिए आपको क्या करना है? You should use A. A means append, means open or create a file for writing at the end of the file. Obviously, if you just want to open an existing file and you have already created the data and that data is present, so you should not overwrite it. So by A means you want to open it up and you want to write it, mean update the file means you want to add on the information, and this add on you can do with the help of the mode A. You open it up the file in the append mode. Then R plus means open a file for update, reading and writing. So if you want to open a file for reading and writing, so you want to retain the previous data and you want to enter a new data as well, then don't use R plus, use R plus, don't use W, because W will destroy the previous contents, where R plus will enable you to add more contents and read the previous contents as well. W plus creates a file for update. If the file already exists, discard the current content. Just the R plus mein hai, you can just open a file, the contents are create a file. If the file already exists, discard the current content, so don't use if you just want to retain it. Then A plus appends, open or create a file for update. Writing is done at the end of the file. These are almost similar, but just have given you different options to use it, so that you also know what type of option you are using it. Then you can read binary, open a file reading in binary mode. I will come back to this in the later part of my today's lecture, or maybe in the next lecture, when I will show you how can we create binary files. Okay. So for that purpose, if we want to create a binary file, then we can just use, instead of R, we can use RB. Similarly, WB for writing binary files, append binary files, read and write binary files, just like this one. This is for the character files, and this is for basically the binary files. So the upper half is for the files if you are dealing in a character by character formats, and the lower half is basically if you are just dealing the binary file. What is that? I will explain it to you later on. So reading a sequential file, we have already created a file, and this time we want to read from the file that we have already created. Remember, the file that we have created has a name clients.dat. So this time we would like to open the same procedure. We will open a file with the help of fopen. We will put a pointer there. This pointer will provide you the pointer, and then you can use fscanf function to read the data. This fscanf function has this additional argument, and let me pick up the pen first. This is the additional argument, okay, and this is a pointer that indicates that from which file you are going to read, and this is the format. मैंने आपसे कहा था ना कि scanf, if you want to read in the formatted file, or if you want to write a formatted file, so it will read the first account in decimal, then next name in string, then floating point data in balance. So data read from the beginning to end, it will keep on it will read one record, this because you are reading only 3, so it will be reading this 3. Then you can just keep on reading until you have a pointer which indicate that you are at the end of the file. Then something very important, file position pointer. File position pointer क्या है? It indicates the number of next byte to be read or written. So this is different from the file descriptor. This file position pointer is basically the offset, is the displacement from the start of the file. So if you are somewhere in the middle, then you can see that this file position pointer that indicate the number of next byte to be read. So जैसे हमने we have read it with fscanf, suppose we have read the first few bytes, record का तो structure है नहीं उसके पास, so it must have read few bytes also. That means that it must have read account number, then the name, then the balance, and then it should be indicating a particular byte, and that byte will be the position from where the next record starts. Okay. So this file position pointer is not really a pointer, but an integer value that specifies the location. So इसको हम कहते हैं offset or displacement, okay, from the start of the file. Rewind. What does rewind does? Basically, rewind takes you back to the start of the file. If any stage you want to go back to the beginning of the file, in that case you can use a function, and that function is rewind cfptr. means you are required to go back to the beginning of the file and then you can start reading the data. ठीक है, it reposition the file pointer to the beginning of the file. So let's read the data from the file now. Int account, वही similar, the same, because we should know that we have written the data in the format account integer, then we have the string name, then we have a double balance, and जिस फॉर्मेट में हमने राइट किया है exactly उसी फॉर्मेट में we are required to read it back. Then we declare a file pointer. Open the file, just like we opened the file at the time of writing it, but this time the mode is R. If we find the file, for R the file should be present, because you are not creating a file, you want to open a file to read. So this time the whatever names you have provided, the operating system is required to search that file. So the operating system once searched the file, then it associates a pointer and returns it back. If the operating system does not find that file or does not locate the file for you, in that case the operating system will return a null and you will say that the file could not be opened, means the file is not found, or even could be any other reason. But if the file is found, then the pointer is loaded, then it is not null, then you can start reading the data. So first because you want to place the data read from the file onto the screen, so you can use printf account name balance and then formatted read. This formatted read is just like scanf that was there in the previous example. Okay, but this time you are using it exactly with the same format, %d, %h, %f, but the only difference is that you are providing the stream here. You are providing the file descriptor here, and this file descriptor knows the address of your file in the file allocation table, and also it also knows with the help of the operating system that what is the current position of reading the file in that particular situation. So if you have already read 40-50 records and 50th record we have just read, so it will be indicating the record number next byte, that should mean the starting of the record number 51. So the same thing, just like in the previous example, first we will read one statement, mean we have an account name and balance, and then we can just put it up a loop, keep on reading until we find end of file pointer, and unless until the end of file pointer is indicated, then we can keep on displaying the information onto the screen, printf function say, and then keep on reading the data from the file descriptor cfptr and in the same format. You will keep on reading it and putting it back onto the screen, and once you encounter the end of file marker, then this will, help of this you can close the file. Once you close the file, then it means that the file is properly saved and is available for the next time. Otherwise there is a chance that the operating system will close it down for you so that it should be available to you. So that file that we have created in the previous example, so you have read it, the same account number, the same names and the same amount that you have entered previously, and with this program that we have read it, and it was basically a data file here, and the name of the file that we said that is a clients.dat file. So now we have learned how to create a file, sequential file, how we can read the data back from the file. So in this particular example we will do both the tasks simultaneously. What does it mean? That we will open up a file for read and write, and then we will carry out different functions. And what are the different functions? Means that we will see that list the account, for example. Okay, let me start from the beginning. This function main begins program execution. So let me see that this is the standard account, this is double balance, this is name, So you have the three fields the same, account is the same, name is the same, double balance is the same, but the another data type that you have added is integer request. Then we have defined a pointer, and then we have opened up the file. So if we have opened up the file successfully, then we are displaying a menu here. One means list accounts with zero balance. Number two means, okay, these are all the activities related to the read-only activities. Means we are not writing any data, means we are not updating any data, and we are not deleting any data. So in option 1, list account with zero balance. Option 2, list account with credit balance, means positive balance, and list account with debit balance. Credit balance means negative, and debit balance means positive, and 4 to end of the program. So we can scanf the request, and while the request is not equal to 4, we would like to keep on reading the data. So first of all, we will read the first record from the file here, and it is again the same format that we have read it. Then we can use the switch statement, and this switch statement is for the 4 options that we have given. So case 1, and case 1 kya tha? The list account with zero balance. So you will say accounts with zero balance, while not end of pointer, keep on reading that if the balance is equal to 0, 0, then printf this one, and then you can just keep on reading the file. So in this way, that you again scanf, you are reading another record and then checking it if the balance is equal to 0 or not. If the balance is equal to 0, you display the result. So this case 1 will be running in the loop again and again, repeatedly it will run, it will execute, and it will display all the records that contains zero balance. Then case 2, accounts with credit balance. This time you can say that the balance is less than 0. Less than 0 means negative balance. So negative balance कब होता है? When we have the credit account. Credit account just like your credit card. Credit card में whenever you purchase something, then your account goes to credit, means negative, and you are bound to pay that amount back to the bank. So that means it becomes a credit account and you have to pay to the bank. So you can check the balance again just like that. If your balance is less than equal to 0, then you can just keep on reading the data. It's very interesting that this time we are not reading the data from the keyboard, rather we are reading the data from the file, and we are handling a professional assignment and professional processing of the data here. Then case 3, for the debit balance, and debit balance means a positive balance. So this time we are checking the balance is greater than 0, so it will takes over, this while loop will take over, and it will keep on reading the data. And for all those clients that have the positive balance, means the debit balance means the ordinary account balance where you usually deposit your money into the bank, and that information can be displayed onto the screen. Rewind. Rewind means since this particular example we are using it a menu here, that you want, maybe one time you want to find out all the records with 0. In the same program you want to use it all the record with debit and all the record with credit. So it's mean that we can just still continue with this here, and we can just rewind it. After completing one activity, rewind will take the control back to the start, and then you can again scan back the request, and then you can check again. This is a switch again. So if it is not 4, it is something else, so it will provide you the facility. So it's very interesting. So if the next time you are required to read the data, suppose first time you wanted to see who are the clients who have a credit balance, next time you want to see who are the clients who have a 0 balance. So in case you want to see who are the clients who have 0 balance, then this is a very useful rewind function that takes the control back. And with the help of this rewind function, then you can just perform the activity that is requested by the user. And at the end, don't forget to close the file. So this is the sample output of this particular application. In the first case, you might have chosen 1, so it means list the account with 0 balance. So it's mean that in our case, Mr. White has an account with a 0 balance. Next time you choose 2, account with credit balance. So any client that has a negative balance, Mr. Stone has a negative balance. Okay, don't worry, I'll be showing it to you in the hands-on when I will carry out the hands-on demo. Maybe after completing this particular complete chapter, I'll be giving you hands-on demonstration. So just relax and don't worry, but just try to understand the concept here. Then activity number 3, accounts with the debit balance, all the balance that are positive. So you can use it at the end when you say 4 means the end of the program. So what we have seen, the reading data from a sequential file. Let's conclude it. Sequential access file cannot be modified without the risk of destroying other data. What does it mean? That once you have created a sequential file and suppose you want to read the data, and there is a very fair chance that you might destroy the data. How can you destroy your own data? So I can explain it to you. So the size of the field may vary. For example, if we want to change this percent Y to Worthington, from Y to Worthington, you say that this account has been transferred from Mr. Y to Mr. Worthington, and don't delete the account, just change the name of the account. So what will happen? Okay, look it very carefully. The old file will contain 300. If it is an integer data, it must be 2 bytes. If it is or it could be a 4 bytes. So the 4 byte will contain this information. Then it will contain 1, 2, 3, 4, 5 and a null terminator. 6 bytes will be there that will have the White, means the name of the person. Then it will have next could be another data that suppose is indicated your account balance, and then comes the next employee account number 400. Now this could be the 4 bytes here, that means representing the float data here. So 4 bytes, 5, 6, 7, 8, 9, 10, 10 and 4, 14 bytes here. Now you want to change Y to Worthington. So what will happen? From here you will add on WOR, TH, and from I you will insert 1, 2, 3, 4, 5, 6 bytes. Where this 6 bytes will go? This 6 bytes will be will occupy the space adjacent to these bytes. क्या होगा? जो next field है, whatever the next field is, and in our case the next field contains the account balance. So these the overflown bytes will destroy the account balance. So it's mean that they will destroy and disturb corrupt the data. Means whatever the accounts data that you contain and maintain for one particular client will be lost and will be destroyed. So that is the reason that we cannot update any record, or we should not update any record in a sequential file, because in the sequential file you do not have the concept of record, you do not have the concept of any structure, you just have a stream of bytes. And if you have the stream of bytes, then you don't know that how many bytes has been occupied by that particular record. So that means that the sequential file जो है उसको update अगर आपने करना है, you can only append. If you want to append it, yes, you can do that. You may keep this record temporarily and add a new record at the end of that particular file. So append is possible, but don't overwrite it, that it will destroy the data. Next is the random access file. I'll give you just a very brief introduction, and then I will come back maybe in the next lecture and explain it to you. But let us just give you another file type. We have seen the limitation of the sequential file, and the limitation is that we can only we once create that file, we cannot update that any particular record. If the record size is exactly, if we remember and we know very precisely, then we may do that, but it's not recommendable. But suppose we want to update the record, and suppose we want to access a particular record directly. Another limitation with the sequential file is that you can access the data sequentially. So if you contain 10,000 records, and if you want to read record number 9999, in that case you are required to read record 9998 first, and then you should be able to read the record 9999. You cannot directly read the record because you don't know the size of each and every record, and there is no concept of record in this sequential file because we have the stream of bytes also. Now you must understand that why it is important to know the concept of the stream and the stream of byte. So because there is no concept of record structure, so you cannot directly jump into the record number 999, but that we can do it in the random access file. So random access file access individual records without searching through other records. Number 2, instant access to the records in the file. If we are allowed to directly go to any specific record, it does mean that we have access to any individual record, and we can have the knowledge and understanding and the position of that particular record, so that we can access that record. So data can be inserted without destroying the other data. We can directly retrieve one particular record, update the data. Then the data previously stored can be updated or deleted without overwriting it. Even if you want to delete, yes, you can delete it. You want to update, you can update it. You want to modify it, you can modify it. Okay, implemented using fixed length record. This is only possible because we have indirectly introduced the concept of a record in the form of block size, in the form of the size. And this sequential file do not have a fixed length record, but for this particular example, if we assume that one byte size is equal to one record size is equal to 100 bytes, so from 0 to 99 we know it is the first record, and from 100 to 199 second record, third, fourth, fifth, sixth, so on, and it means that we have a precise offsets. So we can compute the size of one record, and then we can find out, जिस तरह arrays में करते थे, if we know array में भी तो you can access any element, any subscripted element, but array के case में क्योंकि all the homogeneous data elements थे having the same size, so using that information the system does the same thing for us. So why not we could use the same concept? If we restrict ourselves to a fixed size record length, then we can we also know the starting position, then we can have a very simple mathematical formula to find out the desired record and address of the desired record. So we can create a random access file data in random access files, and this record is not like the other sequential file record. This time it is an unformatted data, means the stored as a raw byte. Stored as a raw byte means whatever the internal representation of the data is, you are bound to use that internal representation. So it's mean that the data not readable by human, because it is organized according to the internal structure of the data. So all the data of the same type, integer for example, uses the same amount of memory. So all records of the structured data will use the same structure, the same data type of each member, and it's mean that you can easily compute the size of the each element. So all records of the same time have a fixed length records, but The difference is that you cannot read it because it is, that's why we call it as in the binary form, and that's why we will be using the word B with R and word B with W and word B with A. Okay, I think let me stop here at this time, and I will explain this creating a random access file in the next lecture in detail, and I will try to finish it up with some good examples so that you can have a good understanding. So with this I conclude today's lesson, and see you with the continuation of the same topic, means file processing, but this time next lecture we will be discussing the random access files, and start with the creating of the file exactly from the same slide in the next lecture. Till then, Khuda Hafiz, Allah Nigeban.